All right. Well, I'm gonna, I guess, mostly tell you a story today about how I ended up in this fun position. So, weird thing, I get to have two different QR codes here because it may be useful to pull the textbook up while I'm talking as well. I don't know. And then I will just reset the Zoom and hope that the rest of the slides work. We'll see. All right. So I'll start with like how to accidentally write a textbook, because this was not something I set out to do at all. And then talk through some of the design decisions and some of the things I found from teaching R and Python together. And then what conclusions I can come up with, which, you know, this is an ongoing thing. So I'm not sure that there's a whole lot of long-term conclusions just yet. But all right. So how I accidentally ended up writing a textbook. So I started at University of Nebraska in January of 2020, which was a great time to start a tenure track position. I remember in February, I was really, like, my chair called me in and was like, hey, I want you to teach the online intro section next spring. And I was like, oh, I'm really not sure that I've got what it takes to teach online. Well, that was fun. So I was assigned to teach the graduate computing class in the fall, and I was told that they learn R and SAS, and traditionally they'd done 8 weeks of R and 8 weeks of SAS, more or less. And I'm like, I have to teach R and SAS? And then I have to learn SAS? And of course, this is fall 2020, we had no idea what was gonna happen, right? So we were technically in person, but we're told we could end up having to go online at any time. We had a compressed semester. It was fun. So I was trying to plan this class out with no idea what the format would end up looking like. And I was like, okay, well, they say flipped classrooms have a little bit more flexibility, and hopefully that'll allow me to, you know, pivot to onlineness, because the computer lab is pretty easily moved online if everybody has their own machines, but a chemistry lab, not so much, right? So, and then I started thinking, okay, what's the outside class material gonna be? Is there a SAS equivalent of R for data science? Not so much, as best as I could tell. So I hate listening to videos of myself. I hate the audio. I hate the video editing process. I hate how stupid I look on a screen. Writing a textbook seemed like a much less painful process, which is maybe not my best idea ever. So I spent that summer madly typing and trying to learn SAS. And so I would write the R code that I thought they needed to know, and then I'd go try to figure out what the SAS equivalent of that R code was. And most of the time there wasn't SAS equivalent of that R code, and the rest of the time it involved some complicated IML stuff, and that was weird. Anyway, the class went well enough. I was told, I think, that first semester, this is the most organized computing class I've ever seen. And I'm like, huh, I feel like I'm a dumpster fire of flying papers everywhere. The next spring, I started teaching we had just added an undergraduate major when all of this went down. And so I started designing the computing sequence from the ground up, and had to teach, we had decided to do R and Python, because that was what students would need to know for like internships and things like that. We wanted them to be able to take electives over in computer science, and of course computer scientists poo-poo R all the time, right? So it was another, oh crap moment, I have to learn Python. So I started writing a new book, translating all the graduate textbook stuff into undergraduate sized chunks, and then substituting the SAS chunks for Python chunks. It was nice to remove the SAS, really. But I got real bored fixing things in both textbooks simultaneously. Like, that was miserable. Quarto came out in 2022, And I was like, okay, this is a great excuse. I'm just going to combine both textbooks and you keep the undergraduate size chunks, and I'll just assign multiple chapters. The grad students will grumble, but whatever. They'll be short chapters, right? It'll be fine. And so my goal was to kick back and relax and only have to maintain one version of this ever-evolving monstrosity. So Quarto was amazing, by the way. Like, I had a really hackish way of doing the tab set panels in Markdown, and it just like freaking worked in Quarto. I don't think Quarto gets enough credit for how much easier it made dealing with images and this kind of web content. But it was heaven switching that over. I mean, it was a real pain in the rear as well, but so since then, I've been, as we've continued to have the first cohort of this undergraduate program move through all the computing classes, I've been designing a new computing class every year, basically. And so I have been adding chapters to this thing. And hopefully we have one more computing class left that hasn't been taught or won't be taught like as of fall. So hopefully that will come to an end soon. But I've been also updating chapters as package updates came out, and students were confused by this or that or whatever. And then this summer, some of you probably have heard from your various compliance offices on campus about Title II and how everything has to be completely screen reader accessible. Like, I was pretty decent, I think, at adding like alt text and stuff, but like being able to completely tab navigate through the book is not great. So we're working on trying to fix that kind of stuff this summer. And then since I have grad students doing all the accessibility audits, I decided, why not just have them also find all the typos? So doing a little bit of light editing, and then I've been adding chapters for the advanced computing class for undergrads, so things like APIs and web scraping and all of that stuff. So anyway, this has continued to evolve, and I'm hoping maybe it will be relatively, hopefully done sometime soon, maybe. All right, so the design decisions I made. So the whole story of how this happened, right, is all to say that when I started this, I was trying to come up with something that was a good substitute for me recording lectures, right? Which meant that I needed to include all of the bad jokes and comics and bunny trails that I would normally add to my lectures. All the GIFs of like that lovely pivot, longer pivot, wider, tidy explain type stuff. And I wanted to be sure to like show more or less exactly the same thing in both languages. Like, so those tab set panels, I have like R, and then I have Python, or I have base R, and then I have tidy R, and then I have Python with matplotlib, and then I have Python with pandas or Seaborn or whatever, right? But the goal with this is to focus on the operation and not the syntax, because you can look the syntax up. When I started this, you couldn't just go to ChatGPT and say, hey, what's the equivalent Python code for this R code? But now you can, right? But you still need to know what a pivot operation looks like and what to be on the lookout for, no matter what language you're using. So I also really wanted to center the importance of reproducibility. So when I started this, I was using the SAS Markdown package to keep my workflow, because I wasn't about to like start using, first of all, I use Linux, so SAS looks like prehistoric on Linux. It's not that great on Windows, I think, but it's really bad. So I wasn't gonna lose my Markdown-centered workflow by having to teach SAS, so everybody got to use SAS Markdown. That was fun. It's the first time in my life I think something has gone smoother installing on Linux than it did on Windows. But I also was trying to strike a balance, right, between being very opinionated about which tools to use and trying to be fair. So, like, I would be very, very clear when I was teaching SAS that the best way to make good graphics in SAS was to export the data, import it into R, and use ggplot. But at the same time, like, I didn't want to be like, SAS is terrible. except for graphics. And so I was trying to strike this balance of like, okay, use the best tool for the job. Sometimes there isn't a good tool in your language, but also both of these languages are okay for most things, right? And I've tried to continue that with Python, though I am afraid my students sometimes do pick up a little bit of my annoyance with the fact that the syntax for Python data science stuff just doesn't have quite the nice feel of tidyverse. So I'm still working on that. I also wanted to kind of keep the informality of like just turning to the whiteboard and sketching things out badly, right? And so I've kind of kept the like sketchy diagrams with Excalidraw and just, you know, pseudocode type stuff and all of those things. And then, like I said, the tab set panels have been kind of critical for me because I've got, I think I also have an alarm going off to tell me to check in for my flight tomorrow, so sorry about that, bad timing. But so I'll like pose a problem for them and then provide like, here's a sketch of how this should work in either language, and then here's the solution in R and the solution in Python type thing. I like to think that they are diligently working through these steps before they look at the code. But one of the things that I've been contemplating is maybe whether I can use WebR and there is a Python sort of equivalent, but I can't remember the name right now, and like force them to actually write the code. That would be better, I think. But this book is already sort of complicated because the package dependencies are insane. So I've been kind of teetering on the brink of, do I really think this is a good idea or not? But once I got rid of SAS, it was now feasible to build the book with GitHub Actions. And that has been fun, right? So it was like the angel devil sort of motif of, you should totally do this. Yeah, you should totally do this. It'll be awesome. Yeah. I broke the GitHub action for this thing, and I'm pretty sure it's due to some of the caching. But 3 days ago, and haven't been able to get it to work. So I'm not, yeah, it's lovely and ensures that everything functions, but also induces some fun problems when it doesn't go perfectly, right? So there's a ton of package dependencies in both R and Python because I'm trying to show the students how to use all of these different things. But Python dependency management is interesting. And I ended up actually writing my own script to handle the Python dependencies because pip just wasn't doing it for me. And so, yeah, there's definitely some room for improvement there, but most of the time it works in the same way that most of these open source packages work, which is, you know, duct tape, baling wire, and a prayer. So anyway, the reproducibility of the book is pretty decent, but it definitely is also a bit of a pain when you fix a typo and all of a sudden everything breaks because somehow the Ubuntu package dependency list no longer includes a critical library that you needed. So that can be a fun thing to chase down, but I really do depend on the dependency caching a lot because it takes more than an hour for the book to build when there's no caching, because you have to install all of the Python packages, all of the R packages, all of the libraries, all of the stuff, right? It takes, when things are going right, about 5 minutes with the caching. So the caching helps a lot, but when it goes bad, it really kind of goes bad. So another one of the design decisions that I kind of have come to is there's a lot of information in this thing. It's very easy, I think, for people who don't like to read to get overwhelmed because I haven't been successful at striking a balance between like the amount of code and output that I want to show, because I want lots of examples, but lots of examples are also overwhelming, and you can lose the important content in the examples, right? And so I thought, oh, right. Okay, let's see, get back to the right window. And then, so I thought it would be useful just to show how this can quickly spiral out of control, right? So I've got, this is just a intro to graphics chapter. I've got Seaborn objects, RBase, matplotlib, and then some explanation for each one of these things. But then you also want to show like a generic graphing template, right? Like, here's how you would put a plot together. I try to break things up. Alison Horst's drawings are just so beautiful, and because they're CC licensed, like, it's like, why would I not want you to stop and take a little bit of a break and look at this beautiful picture, right? So I have a warning at the front of the textbook about content overload, and I've been starting to think through ways to sort of mitigate that a little bit, but that is definitely a design choice that I've kind of stuck with because I'd rather give them more information and let them kind of skim it so that the answer is there when they go back, when they have a problem. Maybe I should just be training a chatbot on all of the stuff that I should cut out of the book. Maybe that should work. But a few observations that I've noticed in practice. Students that aren't English dominant, like English is not their first language, have, it seems to me, a little bit of a harder time learning a programming language or two programming languages in an English lecture environment. So I got a lot of comments from students whose English skills weren't quite as strong, that they really, really preferred the textbook format to the lecture format for the class. And in some cases, I did go dig up an R for data science translation, which was kind of fun. So other students tend to spend way more time outside of class on this, but they would have been probably lost in the lecture format. So whether that's a pro or a con, I'm not sure. I use reading quizzes to kind of remind them to look at the textbook before class, because if there's not a due date, well, it's not going to happen, right? But that's definitely not like a universally successful motivator. Some students just don't care. But overall, it was reasonably successful, I think. So teaching R and Python at the same time, rather than the, half the semester on one, half the semester on the other sort of thing, is really, I think, important to focus on the concepts and to say, okay, here's the concept, here's how it's done in each of these languages, right? And data science languages change. Like, it was SAS or R when I was in grad school. Nobody was using Python for anything. I don't know what's going to happen in the future. Maybe Julia will finally take off, or maybe we'll settle for something like Rust or Ruby or I don't know what. But that's the point. Nobody knows what. So it's more important to focus on the concepts, I think, so that students can pick that up in any language. I also want them to know how to read and understand documentation, because RTFM is a miserable thing when you're lost, and does not help at all, right? So knowing how to get help, knowing how to look for help, and focusing on those skills, I think, is a really important thing that comes along with, here's how you do it in R, here's how you do it in Python, where do you go to look for how to do this somewhere else, right? So the how is a little bit more interesting. I give them baby tasks in both languages to kind of reinforce that they need to use both. And then for harder tasks, I let them pick. And then sometimes I'll give them bonus points if they do everything in both languages. So keeps the advanced students kind of engaged because they usually won't know both. And the ones that aren't as advanced do okay just mastering one language and the concepts. And for exams, I let them use either language and mostly ask questions about concepts and planning and stuff like that. So they get frustrated. It's a lot. But some of them find the internships and experience thing to be motivating. And I think some of the visuals in the textbook tend to help anchor some of the concepts a little bit better. They can flip back to that. And they do like being able to comment and tell me, hey, something's not working. I'm using Giscus, so it just goes straight to a discussion or issue, which means that I get like 3 emails anytime somebody does something, and it gets fixed pretty fast, right? I've had a couple of students actually submit pull requests to fix typos, which is kind of cool. So I'm going to skip the other cool stuff. PyScript, that's what it's called. Anyway, I think there's a lot of things that could be improved here. This is a collection of Band-Aids at this point. But there's a lot of really awesome stuff that's come out that can be, could be implemented here to make the textbook a little bit more usable and less intimidating. So anyway, I just would say there's so much of other people's stuff that I've chucked in here. Julia Evans comics, Allison Horse artwork, XKCDs, and memes of all sorts, right? So this is the product of an open source environment that is really cool. So, and with that, I'm done.